Now that we've taken a look at what angles are, we're going to look at ways that we can talk about two angles relating to each other. So the first idea that we have is the idea of something called complementary angles. So we call two angles complementary if they add up to 90 degrees. So if you put the two angles together and you get a 90-degree angle, we call those complementary angles. And we would say that one is the complement of the other. So say if you have a 60-degree angle and a 30-degree angle, those are complementary angles because if you put them together you get a 90-degree angle. We also have supplementary angles. So two angles that add up to 180 degrees or add up to a straight line. We call those supplementary angles. So for example, you could have a 100-degree angle and an 80-degree angle. So 80 would be the supplement of 100 and 100 would be the supplement of 80 because together they make 180. Also, we have this idea of adjacent angles. So the word adjacent means next to. So adjacent angles are two angles that are right next to each other. More specifically, though, they share a common side, so one of the rays that makes up the angles, and the vertex. So the vertex is, again, where the angle actually is, that point where the two sides meet. So adjacent angles share a common side and the vertex, but have nothing in common aside from those two things. All right. In example 1 here, let's name the complementary angles, the supplementary angles, and a pair of adjacent angles. So again, complementary angles add up to 90 degrees. So if we look at angle RST, written like that, and also looking at angle CAB, those two angles are complementary because 58 degrees plus 32 degrees is 90 degrees. So these two angles, CAB, those are complementary angles. Let's look at supplementary angles. So supplementary angles, again, add up to 180. So looking at, say, this angle here in red, and then, again, we're going to look at angle RST. Those two angles together will make 180 degrees. So 122 plus 58 is 180, which means that angle CAD and angle RST, those two angles are supplementary. As far as adjacent angles go, the only set of adjacent angles here is, we look at this green angle and this blue angle. These are adjacent angles. Put them together, you get this red angle. Those are adjacent angles. So they share a common side. That's this side right here. In black, that's the common side. The vertex is right there circled. So they share a common side, they share a vertex. These are adjacent angles. All right, so we could say then that angle CAB and angle, let's see, CAD are adjacent angles. Example 2. Find the measures of a complement or supplement. So let's say that angle 1 is the complement of angle 2, meaning that they add up to 90 degrees. And if the measure of angle 1, so that's again what the M in front of angle 1 there, means the measure of angle 1, that's how many degrees it is. If the measure of angle 1 is 68 degrees, then find the measure of angle 2. Well, there's a couple ways you can think of this. One way you could think of it is that the two angles together, so say the measure of angle 1 plus the measure of angle 2 has got to equal 90 degrees. Well, we know the measure of angle 1, it's 68. So if we add to that the measure of angle 2, we get 90. Well, we could solve this equation then for the measure of angle 2. So let's subtract 68 from both sides. 90 minus 68 is 22. So the measure of angle 2 is equal to 22 degrees. All right, so that's kind of the long way of doing it. But you could have just thought, well, what do you have to add to 68 in order to get 90? Well, that's 22. All right, part B. Angle 3 is the supplement of angle 4. The measure of angle 4 is 56. Find the measure of angle 3. Again, we could set up an equation like we did last time, or we could just think, well, we've got to take 56 and add something to it to get 180. Or another way to think of it, if we take 180, subtract 56, that'll tell us what we need to have in order to have it add up to 180. So the measure of angle 3 then is 180 minus 56, which is 124. So that's got to be a 124 degree angle. All right, some more terminology. Linear pair. So a linear pair is when we have supplementary angles that are also adjacent angles. So they kind of add up to 180 degrees, they add up to a straight line, and they're right next to each other. So two adjacent angles that their non-common sides are opposite rays. So remember that opposite rays are rays that have the same endpoint but point in opposite directions. So for example, this ray and this ray, both coming off of, say, point A right there. Those are opposite rays. So then if we were looking at maybe like an angle here, so we've got B, C, and D. Well, we could look at angle BAC and angle CAD. Those two angles are a linear pair. So they are adjacent to each other and they add up to 180 degrees. They add up to a straight line. Now we've also got this concept of vertical angles. Now this one, I want you to make sure that you get this in your head. This is a very important idea that we will be using for the rest of the year. So vertical angles are two angles that are opposite each other in the intersection of lines. So if we have two lines intersecting each other, there are two sets of vertical angles. So one set of vertical angles that we have is this top angle and that bottom angle. Those are called vertical angles. And then the other set is this angle on the left and then the angle on the right. So there's two pairs of vertical angles. So those marked in green with one mark, those are vertical angles. And then separately from that, in blue with the two marks, those are also vertical angles. All right, let's look at example 3. Identify all of the linear pairs and all of the vertical angles in the figure below. Okay, well, oh, pen's not working. Okay, hang on. Okay, appears to be working again. So if we look at this line here, and that is a straight line. We look at maybe this line coming off here. Well, I've just divided that into a linear pair. So we've got one angle coming around this way, another angle coming around this way, and those two angles are adjacent angles because they share this vertex and then this blue ray. But they are also supplementary. They also add up to 180 degrees. So that is a pair of it's a linear pair. So we could say angle 5 and angle 4. All right, we could have another linear pair. If we look at, say, this line here and this ray over here. Well, angles 1 and 5, those will make a linear pair. Again, they're adjacent to each other. They share that vertex. They share that green ray. And they add up to 180 degrees. They add up to a straight line. So even though we don't have any markings for how many degrees these things are, if they add up to a straight line, then we know that they have to be 180 degrees because 180 degrees is a straight line. So we could say angle 1 and angle 5. That's also a linear pair. As far as vertical angles go, well, what we are looking for again is where we have two lines intersecting, looking for the opposite pairs. So if we look at, say, this green line and this red line intersecting, well, we've got an angle right here that is opposite an angle right there. So we can say that angle 1 and angle 4, those are vertical angles. And as far as this picture goes, there's no other sets of vertical angles. So it would be true that, say, this angle 5 right here, and then this angle going all the way across here, including angles 2 and 3, that would be a set of vertical angles. But 2 and 3 are split up there, so We couldn't say that 5 is vertical to 2. We couldn't say it's vertical to 3. If we combine those together and made it some other, maybe we call this angle 6 or something, then we could say angles 5 and 6 are vertical angles. But as this picture stands, that's it. And last example. Example 4. Two angles form a linear pair. The measure of one angle is 5 times the measure of the other. Find the measure of each angle. So we are not given any kind of degrees other than the fact that they are a linear pair, so they add up to 180. But we are given a relationship between them. So if they add up to 180, they add up to a straight line, which means we're going to have something that looks, something like that. And I'm not going to be worrying about my accuracy of the graph to see that, or the accuracy of the line to see that, one of those angles really is 5 times bigger. We'll just kind of get a picture to see what's kind of going on and do the rest with the algebra. So if one of the angle measures is 5 times the measure of the other, well, what we could do is we could say, let's call this one x. And then if the other one is 5 times that, well, that'd be 5x. And we know that when we add those two angles together, we've got to get 180 degrees. So if we take 5x and add to it x, we're going to get 180. Then we just solve this equation. So 5x plus x is 6x. Then we can take 180 and, both sides divided by 6. 180 divided by 6 is 30. 6x divided by 6 is x. So that tells us that x is 30. We're not totally done yet though. So we have found one of the angles, because one of the angles is x. So this one is 30 degrees. But we've got to find both angles. There's a couple ways we could think about this. One way we could think about it is take that 30 degrees for x and plug it right in here for x in 5x. So 5 times 30 then, that is 150. So this is a 150 degree angle. Another way we could have thought of that is that the entire angle going all the way from here all the way over here has to be 180 degrees. So if we take 180 and subtract off this 30 degree angle that we already found, we'll also get 150. Another way to do it.